what lies above and below the solar system? A journey beyond the ecliptic plane. When we picture the solar system, most of us imagine the classic textbook diagram. 8 planets neatly lined up, orbiting around the sun like marbles on a flat tabletop. But the true nature of our cosmic neighborhood is far more dynamic and complex than this orderly image suggests. A flat but tilted system. Our solar system is essentially an orbital disk, a relatively flat plane of motion where the planets travel around the sun. This alignment isn't random. It was inherited from the primordial cloud of gas and dust that gave birth to the sun and its planets billions of years ago. Most planets orbit close to this plane, which roughly aligns with the sun's equator. Yet each planet has its own subtle tilt. For example, Mercury's orbit is inclined by about 7 degrees, while Pluto's, now classified as a dwarf planet, is tilted nearly 17 degrees. Comets are even more rebellious. Many come from distant regions and follow wildly tilted orbits, slicing across the solar system like needles through a vinyl record. Redefining up and down in space. On Earth, gravity gives clear meaning to up and down, but space lacks this universal frame of reference. There's no fixed floor, no absolute ceiling. What we call above or below is only meaningful when compared to a chosen plane, in this case the plane of the planetary orbits, known as the ecliptic. Using this plane as a reference, astronomers can explore what's above and below the solar system, revealing astonishing structures. The Oort Cloud, a cosmic bubble. Stretching up to 100,000 astronomical units, AU, from the Sun, more than 1,000 times the distance from Earth to the Sun, the Oort Cloud is believed to surround the solar system like a massive spherical shell. Unlike the flat Kuiper belt, home to Pluto, the Oort Cloud is 3-dimensional and isotropic, meaning it envelops the solar system from all directions. Composed of icy remnants from the solar system's formation, it was shaped by gravitational interactions with the gas giants, which flung these objects into distant orbits. We've never observed the Oort Cloud directly, but long-period comets, which appear to come from all directions, strongly suggest its presence. The Heliosphere, our solar bubble. Encasing the entire solar system is the Heliosphere, a teardrop-shaped bubble formed by the solar wind, a constant stream of charged particles emitted by the sun. This bubble acts as a protective shield, pushing against the surrounding interstellar medium. The outer edge of this region, where the solar wind slows down and starts mixing with interstellar particles, is known as the heliopause. Beyond it lies true interstellar space, the local interstellar cloud and the local bubble. As the sun hurtles through the Milky Way at over 828,000 kilometers per hour, it moves through different regions of space. Right now, it's passing through a slightly denser area called the local interstellar cloud, a pocket of gas and dust in the galaxy. But even this cloud exists within a larger structure, the local bubble. This massive 300 light-year-wide cavity in space has much lower density than average and is thought to have been carved out by ancient supernova explosions. These blasts cleared away gas and dust, creating the walls of the bubble, dense regions that still interact with passing stars and clouds. A galactic perspective. Zooming out further, our solar system is just a speck within the Milky Way. The galaxy itself isn't a flat disk either. It has a central bulge, spiral arms, and a warped edge. Encompassing it is the galactic halo, a spherical region containing older stars, star clusters, and vast quantities of dark matter. By analyzing movements above and below the galactic plane, scientists can study how stars form, how galaxies evolve, and how dark matter is distributed. A fragile oasis in the vastness. Understanding what lies above and below the solar system transforms our view of the universe. Instead of a tidy arrangement of planets, we see a vast multi-layered structure filled with icy remnants, energetic winds, ancient stellar explosions, and invisible forces shaping it all. Amid this cosmic chaos, life flourished on a small, fragile blue planet. That fact alone, that life emerged in the middle of such overwhelming complexity, makes our place in the universe not just scientifically fascinating, but profoundly extraordinary.